Physics 30s, Mr. Thompson here. All right, we're working on questions on the Compton effect, page 105 of the workbook. Question number 1. A 5.8 picometer photon deflects off a stationary electron as shown. Determine the wavelength of the deflected X-ray photon. Answer in picometers. Okay, well, the wavelength should increase after this interaction because, of course, any energy lost by the photon is gained by the electron in terms of its kinetic energy. So our change in wavelength is h over mc, 1 minus cosine theta, where the angle, theta, is the angle of deflection of the photon. So you can see here that if this is our positive x-axis and the photon is going 20 degrees down this way, okay, from vertical, then what we have here is we have a RCS angle rotating counterclockwise from the positive x-axis of 180 to here, and then 70 more, so we're looking at 250 degrees RCS. All right, now let's go ahead and calculate this. 6.63 negative 34 for Planck's constant, 9.11 e negative 31, 3 times 10 to the 8, and then 1 minus cosine 250 degrees. All right, change in wavelength. Let's try this out. All right, 3.25561 e negative 12 meters. And so really this is 3.2556 picometers. So then the final wavelength should be the initial wavelength plus that change in wavelength. And so we have 5.80 plus 3.2556 gives me a total of 9.06 picometers. Oops. I guess it's a good stopping point.